Hi, this is the second part of a constant velocity review. Specifically, it's about outcome number 2. Um, and it doesn't have a huge weighting, but it does show up. And it's about differentiating between position, displacement, or distance and displacement. You should be able to tell the difference between them. And I get a little bit more specific here too. Given a description in words, or given a graph, or given a motion map, so given one of those, you should be able to find the object's position, you should be able to figure out the object's displacement, and you should be able to figure out the object's distance traveled. This is also related to average speed and velocity, so I threw this into this outcome as well. So just as a reminder, average velocity, and we put that little line over top to show average, is the total displacement divided by the total time. Average speed, I like to use the letter S for speed, is equal to the total distance over the total time, so I just use a D instead of anything else for that. So let's take a look at the first part. It says at time equals 3 seconds, what is the object's position? So at time, here's time, at time equals 3, here it is, so the position is at 3, so we could say the position is equal to 3 meters. What is the object's initial position? So the initial position is the x0. So at time 0, it's over here. We could say the initial position is equal to 7 meters. Between these two times, between time equals 0 and time equals 3, what is the displacement? So I could say delta x is equal to the final position minus the original position. So in this case, it would be 3 minus 7, or even I'll write my units in here, 3 meters minus 7 meters, which is equal to minus 4 meters. Another way you can look at it is you're talking about between here and here, the object went downwards and went downwards by 4, so down 4 meters, or in the negative direction 4 meters. Between 0 and 3, what is the average velocity? So we just said, well, average velocity is equal to the displacement divided by the time. And if the displacement was minus 4 meters, and how much time went by? Well, between my initial spot here and my final spot there, my delta x was equal to -4, and my delta t over here is going to be equal to 3 seconds, because it went from 0 to 3. So I'm going to say 3 seconds. So it'll be -4/3 meters per second. I like the fraction form, but I know some of you like to punch it into your calculator. You get -1.3 repeating meters per second. Well, a similar question. We're just going to move the times around a little bit. What about between 3 seconds and 12 seconds? What is the displacement and the distance? Oh, now we have also distance traveled. Well, let's talk about the displacement first of all, between 3 and 12. Okay, so I'll just wipe this clean here. So between 3 would be here, and 12 would be over here. So I'm just interested in here, this will be my delta x. So my delta x is I started at a position of 3 and I ended at a position of 0. So this is going to be equal to -3 meters. Now my distance traveled, d, is actually a little bit harder to think about. Well, I'm not worried about direction. I'm saying, like, what would be my total path length here? So I started at 3, and then I went up to 5. So here I went 2. Okay, here I didn't go any because I stayed motionless. Here it's 0 again. From here to here I went from 5 to 0, and it doesn't matter if I went in the positive direction or the negative direction. I went 5. So what's my path length? How many steps would I have taken? So 12 plus 5 is 7. Okay, the last part says between these, it's the same intervals. What's the average velocity? So average velocity is going to be equal to the total displacement divided by how much time went by. The total displacement I figured out from the previous question was -3. How much time goes by from 3 to 12? Well, what's 12 minus 3 equals 9, so it'll be 9 seconds. So here it'd be -1/3 meters per second, or we could say -0.3 repeating meters per second. So now when I'm talking about average speed, speed is equal to the distance divided by time. So my distance I figured out earlier was 7 meters, and again my time is going to be equal to 9 seconds. So I will get 7/9 meters per second, or if you like the decimals, it would look like that. So here are my two answers. Okay, pretty straightforward. I do have another page here. This is your turn, and there's a fair bit here. There's a little graph to make, and there's a similar question. So I will ask you to pause it now, do all the questions, and then hit play again to see how the answers look. So please press pause now. Okay, well, I filled in the position time graph, put the dots in. Now some of you might actually take issue with the fact that I'm making a bit of an assumption when I draw these lines here, because how do we know that the object was moving at a constant velocity? Like perhaps it might have gone like kind of more like this. So it's true, in which case your distance values would actually get larger because the object moved around more, but your displacement answers would be the same. But I think we're going to use the Occam's razor here and just say, let's use the simplest path. So we're going to just do straight lines whenever we don't know, because we really only know the data for the dots. We don't know for between the dots, but let's make that assumption and not worry about it. I'm sure most of you didn't even think of it. Okay, so our displacement would have been 6 meters. My distance would be 6 meters, exactly the same. Not too surprisingly, then my average velocity and my distance afterwards would be the same, because it from 2 to 7 is 5 seconds. You're dividing both those by 5. The object's displacement over the entire 9 seconds, well, if it started at the origin and it ended at the origin, the change would have been 0. But for 20 meters, the distance would be 20 meters, would be 4 plus 0 plus 6 plus 0 plus 10. So that would have given us 20. So my average velocity, 0 divided by some number is 0. My average speed would have been 20 divided by 9, 2 2/9, or 2.2 repeating. Okay, and that's it. Thank you very much.